Okay, I'm going to walk you through how to perform a basic urinalysis. So first you want to start by filling out your patient's information on your urinalysis record. We're going to be looking at Riker's urine today, and definitely want to make sure that you note the date that the urine was collected as well as the date that we're running the analysis. We also need to know a general time frame of when the urine was collected so we know how old it is. So this was taken just this afternoon. Also, the collection method is very important to notate. So this was collected via free catch. And then for the sample remarks, you want to just put a mark about the clarity of the sample and the color. So this is his sample here. It is clear, you can see through it, and it is somewhat of a dark yellow. So that's what I've indicated on his form. Now I can begin, and I like to begin by setting up my sediment tube so that it can spin in the centrifuge. And while that's happening, I can run the rest of the urinalysis. So for urine, you can use a couple different tubes. They have to be sterile, non-additive tubes. This is a white top tube that I'm going to be using. You could also use a glass, no additive red top tube, or just a plain plastic tube of any kind with no substance or chemicals in it. But I'm going to use the white top tube. So I need to collect a sample to fill this tube with. The more I can fill the tube with, the better, because that'll give me more sediment. And if this urine sample had been sitting on the counter for more than a few minutes, I would want to make sure to stir it up or invert it a couple times, just in case the cells and the solid matter had time to settle to the bottom. So that tube is full enough, and then I'm going to fill the pipette one more time for the rest of the tests. I'm going to go ahead and place my cap back on my white top tube. Okay. And then you'll want to label the tube with the patient's name and information. If you're doing this in class for a lab skill with multiple people running the centrifuge at the same time, you might actually just want to put your name on the label so you know it's your tube, because you'll probably all be using the same sample. And then the other thing you need for the centrifuge is a balance tube. So you need an identical tube to the one that the sample is in, and it needs to be filled approximately the same amount. So if we compare these two, we can see that the balance tube is just a little bit short on water, but we're not going to spin it at a very fast speed, so this should actually be fine. So you take your tubes to the centrifuge, and you need to place them across from each other. If you're spinning with other samples, you can also keep track of what number you put your tube in. So this one is going in the number 5 slot. Then you close, lock the lid. Now we have to set our settings. So urine is spun at a slow speed, either 1,000 to 1,500 RPM. So right now it's set to 2,500. So I'm going to take the speed down. We don't want to spin urine too fast. Actually, I'll go to 15. And then for time, we only want to spin for about 5 minutes. Oops, I went too far there. So 5 minutes, 1,500 RPMs. Now I can go ahead and hit run. So that sample is going to spin, and while that's spinning, I can come back and perform the rest of my urinalysis. So there's 2 more parts. We have to do the chemistry analysis on the dipstick, and then we have to do our urine-specific gravity on the refractometer. So the refractometer, you just want to lift open the window there, and you want to put a good size drop on the screen, and then close the window. Actually, I have to do that better. I have to set the phone down so I can do that and it doesn't run off. Hard to do things with one hand sometimes. Okay, so I put my drop on the refractometer and I close the window, and you can see the drop was big enough to distribute evenly across. I don't see any air bubbles. And then you hold, you're going to look into it just like it's a periscope or a telescope. So you can see there's a dark area above and a light area below, and where those two meet and intersect, that's where we're going to read our urine-specific gravity. So this refractometer has urine-specific gravity for the dog on the left and for the cat on the right. So Riker is a dog. So looking at the scale, the intersection of the light and dark looks like it's at about 1036, maybe 1037. I'll say 1036. Okay, and that's how you read your urine specific gravity. Then make sure this gets rinsed off under water and then wiped dry in the sink for the next person to use. So I'm going to record that. Urine specific gravity, USG, was 1036, which is actually written as 1.036. All right, next we can come over and do our chemistry strip. So we take our pipette and we're just going to put a drop on each reagent pad. This does get a little bit messy, which is why I like to do it on a paper towel. And then after a couple seconds, when it's had time to absorb into the reagent pads, I usually like to tip it up on its side to blot off the excess. And then I need to pick up the bottle, which is the key, and I need to note the time that I'm supposed to read these. So ascorbic acid should be read between 30 and 60 seconds, leukocytes between 90 and 120. Specific gravity, we disregard this because it's more accurate to do it on the refractometer like we just did. pH is between 30 and 60 seconds, so is glucose, nitrate, protein, ketones, urobilinogen, bilirubin, and occult blood. So it's been about 30 seconds, so we can begin reading these. And what I like to do, especially if you have trouble telling colors apart, is I like to hold my strip right up next to the bottle itself. And that'll help me distinguish which color it more likely looks like. So starting at the bottom with ascorbic acid, it's yellow, but if I lay it in between these two, to me it looks more like the yellow square on the left. So that would be a value of 20. So I will come over to here, and I don't actually have it on this form, so I'm going to write it in. Acid equals 20. Okay. And then we want to continue to read that for the rest of the strips at the right time. So I'm just going to take a quick glance at this. pH, which is that light orange color. When I hold it between the two, it's definitely closer to the 6. Glucose looks negative, nitrites look negative. Protein is, it's probably trace. It's probably that first green square there. Ketones negative, urobilinogen is normal, bilirubin is negative, and then blood is negative. So I'm going to record all of those. So you can write negative, pH I said was 6.0, protein was trace, urobilinogen was normal, nitrites were negative, and it's probably been about 2 minutes now for the leukocytes. That's the one that takes the longest to read. Leukocytes, that second one from the bottom, did not turn any shade of purple, so that is negative as well. Okay, so perfect timing because the centrifuge just finished spinning. Gotta wait for it to slow down. Okay, so that means it's safe to unlock and open. And then I want to remove my balance and my sample tube. So the sample tube has been spun, and you may or may not see if I can get it to focus here. You may or may not see a visible sediment or pellet at the bottom of the tube, but there is always some sediment there. So don't be discouraged if you don't see anything. There will be something for you to look at under the microscope in most cases. So the next step is to take our tube, and you can do this with a pipette, but I like to do it I guess the quick way, which is you take your tube and just turn it over and invert it. Just like that. You don't need to shake it or anything. And then turn it back around. You'll see that there's still a drop of liquid in there, and the sediment is stuck to the bottom of the tube, So it didn't run out when I turned it over. So now all I have to do is tap it 1 or 2 times or 3 times on the counter to knock it loose. And then I pour it out onto my microscope slide. And then you can recap this because there's still more sediment in there that we could use later if we wanted to add stain to it. So then the last thing is take a cover slip and place it right over the urine. And now this is ready to be viewed in the microscope. So to evaluate it, you're going to evaluate it on low power, which I like to use the 10, and you're going to focus and you're going to scan the entire area under the cover slip in like a serpentine pattern. And then once you've done that, you're going to go to the 40x, which is high power, and do the same thing. The 10x, the low power, is going to be ideal for seeing large things like casts and crystals. And the 40x, the high power, is going to be ideal for identifying cells and bacteria. And that's how you run a urinalysis.